All right, so now we're going to get to the final two steps of any CAD project, creating assemblies and drawings. You've probably all have some sort of tab next to Part Studio 1 that says assembly. In your case, it'll probably say assembly 1 and it'll be completely blank, yeah? All right, so an assembly basically takes all those parts you created in the studio and combines them together. So we're going to start by putting our body of the snail inside here. So if you click insert, it will generally default to the current document, which is the Robo Snail and the Part Studio you have. You can insert the entire Part Studio as is, but we'd rather not do that in this case because we have a few parts only, so we may as well just keep them apart. So let's do a snail body. And again, your snail body is going to be a little different from mine depending on how you modified it. But yeah, you'll notice that you can put the snail body here and just sort of click and drag it around. You can still rotate your view and zoom in and out the same way you can with a Part Studio, but this part will move freely. Normally for an assembly, you want to make sure that at least one part is completely grounded in space, one part completely cannot move. And to do that, we're going to be using something called mates, which are basically ways of defining what is bounded to what with what constraints. So the simplest kind that you can use in Onshape is called a fasten mate. It's just your generic, this is rigid to this in this exact position. And you'll create these little mate connectors here. So to zoom in on the origin, there's this mate connector that appears on the bottom. And then if we go to the underside of the snail, if you hover over it, you'll notice this flat sort of circle with a quarter cut out form on the center of the plane. This will generally snap to points or edges only. So if you highlight over a face, it's going to snap to the center point of the face, or it'll snap to one of the points on the edge. So let's just have this on the bottom of the snail. And if you have a connector on the origin as well, then it will snap to that location and you can click the check mark to make your first mate. Hi, what's up? Oh, should I show it again? Okay. All right. Thank you for letting me know. All right, so again, our generic mate is going to be the fastened mate. You can just touch M on your keyboard as well. And once you click on that, this little fastened one, fastened, will appear. And you'll need to select two mate connectors for mate. So start by highlighting this origin right here and try to get your, notice that the orange axis is the one that's pointing up and it's just sort of flat on the XY plane. So once you're in that orientation, you click, and then you'll rotate to get to the bottom of the snail, and you'll select this center point right here to sort of select the center point of the snail's bottom. And once you do that, it'll snap together and you'll have a completed mate. All right, does everyone have that so far? All right, cool. I'm seeing some nods. Again, I can repeat it a third time if needed. It is a bit to process, I understand. Okay, so if you have your one fasten mate, then that's good. We're going to start adding in other features of the snail, and we're going to be exploring different mates as we do so. So to insert, again, you click on the insert button, and let's do the shell this time. So you'll notice that the shell just sort of follows your mouse. Just click wherever and then hit the check mark. So again, your snail body is not able to be moved through space. If you click and drag on it, it's not going to move. Your shell, however, since you just added that, you'll be able to drag it any which way you want. So for now, we're going to put some constraints on this shell so that it stays on the snail's body. After all, snails can't eat their own shells off. So we could just do a fasten mate for everything theoretically, but generally this doesn't really make for good practice. For one thing, when you're applying mates and Onshape, in general, you're not just defining everything as rigid. A lot of times you're defining things as coplanar, you're defining things as being coincident on certain edges or being concentric to one another. So we're going to start by doing that with the shell. Another common feature you're going to see is the planar mate. This generally means that any two surfaces are coplanar. It's an effective way of saying this surface is touching this surface and they translate relative to each other, but they are touching. There's no distance between them. You can add an offset, but that's for later. So to do that, we click on planar 1, and let's click on this sort of flat surface of the snail. Again, there's going to be a mate connector that forms, and it's going to be parallel to the flat part of the snail's back. So we click there once. And now we need to add a second. So let's select the flat part of the shell. If you, because the shell is based off of the snail geometry, if you have a flat on the snail, you'll have one on the back of the shell as well. And they should snap together like this. Now, before you click on the check mark, I want to show you something really important. I mentioned earlier that with the coplanar mate, you have two touching surfaces. You actually can add an offset if you want by clicking on offset. And in this case, we can say, call it 1/2 inch, and it'll either go down 1/2 inch, or if you reverse the direction, it'll, oh yeah, that's an important one too. You can also reverse the direction and have it go above by 1/2 inch. We are going to be doing 0, but I'm showing you this feature in case you ever need something to be planar and parallel, but you need there to be an ascribed distance to it. Another important thing is you can reverse the direction. So in this case, if I reverse the direction, the shell will sort of be upside down like that. Obviously, that's not what we want, but do keep that in mind if you're mating things in the future and the planes are touching, but not quite in the direction that you need them to be. All right, so once you have that, you can go as well. With this coplanar mate we have going on, by the way, if I use the words coincident or concentric, please catch me. The terminology used here is very specific to Onshape. You'll notice that I can still kind of drag the shell around, and it's going to look like it's kind of flying off, right? But you'll notice that it's actually only capable of moving relative to this surface right here. So it can move forward, backwards, left, right, but it can't really move up and down. It looks like it's moving up and down, but actually it's not. So we do need to constrain it a few more ways. So we're going to do that planar mate again. And this time we're going to set this shell, let's click on the center, why not, as being planar to this side of the snail body. And it's going to kind of move out of place at first. Let's see what happens. It moves back, and now it's fine. So now it can only move forward and backwards. So again, this plane should be mated to this bottom plane, and this side of the shell should be mated to this side of the snail. And now we can only move in one more direction. Thankfully, we still do have another constraint we can apply on a flat surface. So we'll do that one more time with the planar mate. This time on the bottom part of the snail right here, this diagonal portion. And on the small but still present diagonal portion of the snail shell. And again, it'll look like it's kind of clipping in, but the end result will be that you have 3 planar mates keeping this snail shell in place. Yes? All right, I'll come over. So at the end of this, you should have a fastened mate and 3 planar mates. I will go to your person now. So what you can do is really fasten and do 3 planar. So one thing I am going to make a point of is generally there isn't really like a set wrong way to do mates. Perfectly fine as well, but if you want to get people to have it fun stuff. So on the shell and just grab it up. Do that and then yeah. You should just be able to like click holes and drag it away. So you want to go to the bottom of the front part of the shell and then the front part of the snail back. Here, I'll show it one more time. I'll demonstrate one more time. All right, I'm going to demonstrate the mates one more time. And one thing I do want to make a note of is there isn't really like a prescribed, this is the 100% right way to go for mates. There are a few ways I would consider to be wrong-ish, but the main reason I'm having you do this is so that you don't start leaning on the fastened mate for everything. Because I have seen that happen across teams and somewhat on this one, and it's not good. So we're going to go through the 3 mates again. Oh, did you have a question? All right, so we're doing 3 planar mates. It's okay if you did a fastened mate, that's technically correct as well, but I want you to get familiar with planar mates. So we'll start with this sort of flat back portion of the snail, and then this corresponding flat section of the shell. Those should snap together and you can check it. And now I'm going to move this shell backwards just so that everything is still more visible. And so you'll use the planar mate and you'll click on this sort of angled portion of the shell. Notice that I'm zooming in until I get to the center point. And then you'll sort of hit that same area on the snail itself. And that's that. And then one more time, you'll hit the snail shell and the side of the snail, and it'll clip into it. It'll look bad, but once you hit the check mark, it'll be fine. So now it's sort of constrained in all 3 directions. It's constrained in the X, the Y, and the Z. It cannot move at all. So again, it's okay if for the sake of simplicity, you just want to do a fastened mate in some case like this, where there isn't really any like hard geometry or any like fasteners you need to be aware of. But again, the reason I want you to try using planar mates is because it's really easy to just do a fastened mate for everything, and it does cause a lot of over constraints and issues in the long run. So you have this assembly, right, where your snail has a little shell going on. So we're going to do the eye now. So we're going to insert the eye, and we'll just sort of put it there. Why not? And I'm going to show you 2 different kinds of mates here. There's going to be a cylindrical mate, and there's going to be a slider mate. Slider mate is going to be the sort of mechanical mate that I show you. So for a cylindrical mate, you'll notice that you have sort of a cylindrical shape, an outer and an inner. So, hi, if I can have your attention, please. Okay, so for cylindrical mate, it's pretty much exactly what it sounds like. You have a cylindrical object that you are mating to a cylindrical surface. So we're going to click on that, and I'm going to have you sort of select the inside of your eye, like this sort of eye stalk right here in the center. And you'll go over to one of the holes in your snail and sort of try to get to where you can select the inside of that hole. It's going to take you a bit of moving. And like, even for me, it's not perfect, but eventually you'll notice that there's 3 white circles. Select the one in the middle. And, oh dear, it's not. Hold on. Yeah, it's kind of finicky when you're dealing with inner holes, but eventually you'll get it. Here, let's try that now. And then here. And you'll have a cylindrical mate. I'm going to show you again because even for me, it was a little bit difficult to select. Then again, when you're going from one CAD program to another, your brain has to like sort of adjust. So one mate connector is going to be inside the cylinder shaped hole of your snail. You'll hover over it and you'll kind of try to orient and move yourself so that eventually you can select the top, center, or bottom of the hole. I'll select the center. And then you'll go to the eye and you'll do the same thing. You'll select the center and it'll sort of, oh, I selected slider by accident. That's what's going on. So again, we're gonna do that. We're gonna rotate your view. Not doing it again. All right, actually, you know what? We will try doing a slider, straight up slider. So yeah, if that wasn't working for you, then that was on me. My apologies. You'll select the center of the stalk for the slider, and then you'll select the center for the hole. And for now, we're going to hit the check mark just so I can show you what this does. So the thing about a slider mate is it is one of those mates where it does exactly what it sounds like and can sort of slide the eye in and out of the hole. We do need to limit this though, because snails can't fully retract their eyes. So what we're gonna do is we're gonna go back into that mate. We're gonna edit it, and this time we're gonna select limits. So let's start by filling in this little gap right here, the Z minimum. And let's say 1 inch. As you can see, that sort of goes in that direction. That is like the minimum distance. Let's go to 0, and it stops there. Now let's see what happens if we select 2. And let's just let this go. You'll notice that I can now sort of drag the eye in and out. That's not quite what we want. So we're going to edit that. Again, with mates, it can kind of take a little trial and error sometimes. So we're going to say -2 and 0 and see what that does for us. And now I can slide the eye up and down like that. Yeah. Yeah, unfortunately, there's no dark mode on Onshape. I was hoping it was like one of those platforms where you could. Hi, what's up? Aw. Okay, so I'm going to demonstrate that one more time with the other eye. You'll want to insert your eye on part, it'll be part 4 for me, part something else for all of you. And you'll hit the check mark. And for the slider mate, again, you'll select sort of halfway through the eye stalk and sort of rotate. It's going to be a little bit difficult into here. And then you can just sort of go to limits and go -2, 0 is what I used. Again, you might need to trial and error it for you to get the values that work. For me, generally, things should be in the positive, but it seems like today they're in the negative. And you'll notice that you can sort of drag the eye in and out, but there is a limit to how far in and out you can drag it. So like this eye can go out here, but it cannot go any further. Then the eye can go all the way to this height, but it cannot go down any lower. So that's the point of the slider mate. After that, we are running a bit low on time. So after I show you the eye slider, I'll show you how to do drawings very briefly, and I'll leave you to do I'll show you the axle first before I do that. But okay, I'm going to delete this eye. Now we only have a one-eyed snail. Too bad. So I'm going to insert my eyeball again. Nice little eye stalk right here. Oh no, I forgot to hit enter. It's okay. Sometimes we forget. So we have this sort of eyeball floating out here, and we want the eyeball to slide in and out of the snail. Because you know how like the eyebrows kind of do like this? We want to do that with the snail instead. So we're going to click on slider mate, and we're going to click on sort of center of the snail's eye stalk. And then we'll click sort of on the inside of the hole. Again, it'll take you some adjustments to get to what you want, but you'll know you'll have it right when you have these sort of 3 white dots and you're hovering over the center one. Then you'll want to click on limits, because this isn't just going to slide into infinity. There is a set position we want for this. So my values were 0 for the minimum and -2 for the maximum. You might have different, -2 and 0. You might have different numbers depending on how you made your eyes. For now, that's what I use. And as a result, there is a limit to how you can move your eyes. So the question over how to get the eye to revolve, we're going to go to the part studio again, and I am going to, let's see. Let's suppress that for now. And let's look at sketch 8. So I'm going to delete this real quick. Right. Okay. So deleting everything, including this guy. So you'll want to sort of hover over your eye stalk head on. And eventually you'll notice that this sort of highlights. So what I did was I just converted it. And then I created a 1-inch circle sort of going through the same center. And I just sort of defined it as 1 inch. Then you have a line that you want to go through the top portion of the circle and the origin. So you can just sort of drag it down. And if you don't have it as vertical, you can select one of these and set it to vertical. And then after that, once you have that base sketch, if that makes sense, you'll want to revolve it. And you should have an inner region and an outer region. So if you select this inner region, and then you select the vertical line as your revolve axis, you should be able to fully revolve it as such. Does that make sense? All right. So we do need to about wrap up. So I'm going to very quickly show you how to add the axle, just so that you have a reference for adding wheels, and then I'll briefly go over drawings. Do we have time for drawings? I don't think we do. That's okay. Yeah. So let's add the axle real quick. Yeah. Part of the purpose of this was I wanted them to sort of get Halloween-y with it. And we see a lot of pumpkin snails, which is really cute. A lot of colored snails, like a lot of purple snails and stuff. I like that. So we're going to add the axle. And in this case, we're going to do a cylindrical mate and a planar mate. So first of all, cylindrical. We're going to have a mate connector here. And we're going to have one on the inside of the snail, kind of, and get it inside as much as we can to there. And then we click on the check mark. Now, in this case, we want the inside to sort of be evenly centered. We don't want it to be able to drag out and in. So we're going to do another planar mate between the plane of this axle and the plane of this side of the snail. But in this case, we want there to be an offset of about 1/2 inch. And when you click the check mark, it does not move. It cannot move in and out. It cannot translate side to side. It just stays in place. And then you can mate the wheel to the axle in the same way. So I am going to ask that you finish up the assembly of the snail on your own. I'm not going to check you off. Do what you can on your own, so that you finish the assembly on your own. Again, I'm not going to check you off or anything. All I ask is that if you do finish, like post your snail on CAD General or something, just so that I know that you did something, or maybe you could just show it off to other people and say, hey, look what I did in the CAD workshop. It's a snail. So one thing I do want to show you real quick, if we have time, is drawings. I'm not going to ask you to follow along. I'm just going to show you what this is so that if you're asked to make a drawing during build season, you don't, get confused. So a drawing is going to be a 2D representation of a part, generally used for machining things. So I'll click on this plus sign and say create drawing. And for now, I'll just use an ANSI inch template. And it'll take some time and it'll pull this up along with all your parts. We're going to do a really simple, let's do the snail body. I guess for fun, try to do the snail body. So I'm going to have the front view here. I'll drag out the side view here. And I want to do a top view here. So you'll notice that there's 3 different views of your snail. Actually, you know what, for your home, if you do want to do drawings, pick a simpler part. I just realized I might have done a badness to all of you. This might be a bit difficult to define. Okay. So you'll notice that you have a top view, a front view, and a side view. For drawings, that's generally what you want to do. You want to have all 3 views so that you can give a general idea of what you're looking at. And if there's a certain side that isn't really identical to the other, you might even want to have more views than this. But the important thing with the drawing is that you can actually add annotations to demonstrate dimensions. To show you what I mean, I'm going to click on dimension. And I'll click on this bottom face here, and I'll put it here. It says 8 inches. And if I want to know how tall the snail is, I can click on, say, this point up here, click on the bottom face over here, and say 5 inches. So the important thing with drawings is just that you want to give a view of each side of your part that's sort of unique. And you want to add the dimensions that are relevant to the machinist. So in this case, I don't need to show the left side and the right side of the snail because they're identical. And I don't really need to show the top and bottom because given the views, the bottom is just flat, nothing special on there. But I might need to indicate the front and back side if the back side is similar to this, but there's different geometry. Does that make sense to everyone? All right, so I think we're about done here. Does anyone have any questions over anything we've gone over? All right, well, I guess I'll close this by saying thank you for attending the workshop. I'll add some more. If any of you have any questions, I can record some bits and add them onto the video I'll send out. I'm really grateful that all of you came here, and thank you for sticking with me through any of the hiccups and ups and downs. This is actually our first time doing a workshop like this over the course of 3 weeks on Wednesday. So thank you for taking extra time to do this training. It really means a lot. All right, thank you. Hi there. I figured I'd record this additional session just so that all of you can get a bit more comfortable with using Onshape. So I'm going to cover revolves one more time, but I'm going to create a separate part studio so that it's a bit more visible. So let's do a sketch on the front plane. And I'm actually going to show you a slightly different way to make those eye stalks. So let's start with a basic corner rectangle. I'm just going to start from here, stretch it out kind of like that. There we go. And I'm just going to make this a very basic 1/2 inch by 3 inch rectangle like that. Why not? And let's see what happens when we revolve this. So when I click on revolve 1, I have this area right here, and I'm going to need to select a revolve axis. So let's see what happens when I click on this left axis right here. As you can see, we are revolving this sort of rectangular shape 360 degrees around this axis, and we end up with a cylinder. So let's see what happens if we select the other one. Well, something very similar happens. We end up with a very large flat disc. Again, it's a cylinder and it is revolved around this axis right here. And I just want to give you a better view of what's happening. So I'm going to click on this again. Let me give you sort of a view of what's going on here. So I'm going to select one direction and I'm going to change the angle. So as you can see, what's happening is you have this flat shape that's sort of being revolved around an axis. And in that process, you're sort of creating a rounded object, something that's round about this axis. So that is what's going on when you create a revolve. Let me show you something else as well. So I'm going to go back to the sketch. And this time I'm gonna sort of round it out. So it just sort of goes up and then out like that. So I'm just gonna select the, what kind of arc do I wanna do? I guess for now, I'll just do a 3-point arc, see what happens. Let's just do something like that and then bring it out. I don't really like that. Let's see, what can we do? I guess for now I'll just draw a circle or something and then cut off the half that I feel like. Let's cut it off there. I'm just gonna doop, doop, doop. And then I'm just gonna define the radius as, let's just do 2. You don't have to follow along with this, by the way. I'm just showing you for the purposes of this. Oh, yeah, I guess we didn't really need that line, did we? No, we do eventually. So let's just trim here, here, and we should probably trim like that. And then here, and here, and here. All right, I'm just gonna leave it like this for now, and I am going to exit out. I know it's not fully defined, I'm just doing this for illustration purposes. So now I'm going to revolve this region, and I'm going to do it around this axis. So you'll notice that a curved surface revolved around an axis will sort of turn spherical, whereas something revolved that's flat around an axis is going to sort of be more cylindrical. You'll have that outer curved surface still, but what's going to happen is the round object is going to be round everywhere, and the flat object is going to have a flat top and bottom side, if that makes sense. I'm not showing you this because I expect you to understand how cylindrical objects and how revolved bosses work. It's actually not something you use very commonly in CAD and in robotics. It's just a nice little tool I want you to have in your back pocket because it is really convenient for you to have. All right, so with that, I actually want to show you something a bit more useful, which is the drawings. So we're actually going to create a new drawing because this might be a bit complex for you to start off with. So we're going to create a drawing. We'll just use the ANSI inch drawing. And let's start with something a bit more simple. Let's go through Part Studio 1 and let's just do Part 3 for now. So I think I showed you this already, but what I like to do for parts is I like to go with a top view and then a front view and a side view. So a wheel is kind of nondescript, so it's pretty nice for showing the basics. And you'll also notice that these get dragged along with that front view. So as I mentioned, some of the things you can do are set dimensions. So I can click on this outer radius and define 1.5 as the diameter, and I click the inner radius, define half as the diameter, and I can define half as the thickness. So yeah, those are some useful tricks. You'll see all these other things here. You can add notes, you can add tables, BOM tables, whole tables, really anything that you think might be useful. I am actually going to see about adding, I actually don't think we need much more here. I'll add a center mark on this hole just because it's a nice way of showing things. And you can also add values here like titles. You can add the drawing number, who drew it, who checked and approved it. And that is all stuff that I'm going to be talking with the leads about implementing this year. But yeah, this is your standard drawing. To go back to the one we started on in class, you can actually go more than just these dimensions. You can also sort of dimension these holes. And you'll notice it mostly just is point to point. So you can do it like that. What I would actually recommend doing though is adding a note right here. Something like this, 3" 0.5 diameter symbol, holes, 2" equal spacing. Or actually, I guess I'll say 4" equal spacing. And that can be your note. I'm going to stretch that out so it's easier to see. And you can sort of add an arrow to it so that we know what it's referencing. So yeah, those are just a few things you can do with the drawings. And again, there's a lot of other things you can do with it, like tolerances or adding hidden lines. For now, I would recommend that in general for Onshape, you get familiar, maybe play around with the drawings a little bit, play around with Revolve a little bit. But more importantly, something I'm noticing across the board is a lot of you seem very uncomfortable using the third button on the 3-button mouse. A lot of you seem to be just using the mouse pad on your keyboard rather than actually using the mouse. Please get into the practice of using your mouse because that is going to be a lot easier for you to use once you start CADing. All right, take care. Let me just